There's something in the on the black one. You have to submit. Didn't see it. Okay, everybody. Last time we finished the topic of speed and travel time studies, which also included delay as well. And we looked at some of the things which are related to volume studies, mainly the things which we already know. This is still the outcome related to traffic data collection and analysis. And the things which we already know from the previous topics, what is volume, rate of flow, demand and capacity, and their units. And we focused on the changes in volumes which happen in a lot of ways, different days, different hours, different seasons, and then it can be in response to certain events as well, which can be planned or unplanned. So that's why the modern transportation systems are relying more and more on real-time traffic data and real-time traffic management. And those systems are called as ITS, Intelligent Transportation Systems. Now they are, I believe they are replacing this terminology with smart transportation and smart mobility. Okay, so even this one is now slightly older. You will find it in the books, but now they are moving towards, they are calling it smart because ITS is long, right? So we need to be smart. But in all these technologies, the main focus is on driver awareness. We should make sure the driver is aware about the road situation, so he can manage his trip accordingly. Okay, so I know where is the congestion, which time is good for me to travel, which highway I can go to, which highways are blocked because of congestion or construction and so on and so forth. And an example of this is not really real time, but you see that they post news about major construction work on the highways. Okay, which segments will be blocked and where the traffic is diverted in that case. Okay, and these graphs are showing the usual variations of traffic on different types of highways in different days and different times. Okay, counting you have already done for your term project as well. You did only for 15 minutes, but you have a taste about it. And we also discussed it in the second lecture as well, the second topic. But that was counting on a segment. Okay, but if you are counting on intersections, then it has some extra considerations. Okay, you have to keep some extra points in your mind. So counting studies which are done at intersections are also called as turning movement counts, TMCs. Okay, because vehicles are turning, okay, they are turning in different directions. Obviously, when this is considered, different movements are considered, then you need to have a visual on the movement of the vehicles. Okay, now this visual can be manual, so there is a person who is looking at the vehicles and where they are going. This will have more accuracy, right? Okay, in terms of the movement. Okay, but in modern days, some of you already used it. You can have a visual which is in the form of videos as well. Done? Okay, so the visual can be in the form of videos as well. So there are cameras which can be attached to the counters, and then those can be used for intersection counts. But the point being, you need some sort of visual on the vehicle movements. Simple counters which you put on the road, on the side of the road, which are just counting, are not enough, because we need the turning movement counts, not the total. Okay, so it's very important for the observer. Again, the observer can be the person, or the observer can be the camera. In both cases, the position is very important. Okay, so if you ask somebody to count the left turning and he is standing on the right hand side of the road, so it's very difficult for him to look at it. Okay, or you have a camera which is supposed to take the count from the road which is going east. Okay, but your camera is on the side of the road. It's not exactly in front of the east side. Okay, so in both cases the position of the observer is very important. Okay, what volumes are we counting? I mentioned it for the delay studies as well. That is the volume which is passing the intersection. Okay, the volume which is passing the intersection. So we are not actually counting the Q volume. We are not actually counting the volume which comes to the intersection. So a car comes and the signal is red. Okay, so the car comes and stops. I will not count it yet. When will I count it? When it will leave the intersection. Okay, and leaving the intersection can mean one of the two things. If the car is going straight, okay, then leaving the intersection happens as soon as the stop line is crossed. Okay, as soon as the stop line is crossed, I will count it as the car has left the intersection. Okay, so straight is very easy. For turning, I'll count the car or the vehicle when it reaches the other side. So my point of observation is not the stop line, my point of observation is the entry of the next side, the other side. Got it? Okay. So coming volume is not counted. Departing volume is counted. Volume leaving is counted. Okay, and then there are rules about it. You have how many movements you can have on an intersection? How many directions and movements? 4 from that you mean 4 directions. Okay. And each direction will have how many movements? 2. It's an intersection. The intersection you don't only go like this. You can. So it's a different movement, right? Yes. 4, right? With the U-turn 4, right? So 4 directions and 4 movements. How many total? 16, right? Okay. And then we have some intersections which may have an extra exit somewhere. Okay. There's one in the driving school, right? They use it to teach us right. He always says right, and your right is always wrong. It's still there, right? Or they removed it? There's a roundabout inside the driving school, and it's still there, right? Good. But the point is, these type of intersections can be there on the real highways as well. So you can imagine how many movements are there, and you assign one person for every movement, and you need 16 people. Okay, this is ideal, right? You have one person for every movement. You need 16 people. Okay, one intersection.
One bus is enough for 16 space.
One bus is enough. Okay. What are you thinking about?
Bring one bus with 16 people inside and everyone.
Very good. So after you graduate, go into management or something. Okay, don't bother us. He is thinking about how these 16 people will go to the intersection. Very unique thinking. Okay, I am thinking about how will we get 16 people. Okay.
2, 3, 16.
Yeah, obviously they are all free and they will go with you. If I ask you to go into a hall which is full AC and this is something beneficial for you, even then you will ask me for bonus grade. If I ask 16 people to go to the intersection, they will ask me for half my wealth, right? Even with ICE. Okay, so point being, you have lots of intersections on your highway network. Each intersection will require many people, and you cannot arrange these people every time, and it's not suitable to do it every time because the study could be short or long or whatever. Okay, so in that case you have to manage more movements with less people. Okay, you have to manage more movements with less people. So how do we do that? We look at volume and the experience or skill of the observer. You have to look at two things: how much volume in that movement, and how much is the skill and experience of the observer. Okay, an inexperienced observer which has less skill may still manage 2 light movements. So there's a right turning okay, and then there is straight as well, but from a minor road. So these movements normally do not have much volume, so he can manage, okay. But that same person may not handle two movements if you give him one heavy movement, okay, because that heavy movement will continuously take counting after counting, right? It will not have any break, okay. So if you give him multiple, then he will make more errors, okay. Clear or not? Okay, so you have to keep in mind how many movements you assign, and this will depend upon the volume and the skill of the observer, okay. Less volume, more movements can be assigned, okay, but more volume you should assign less movements, okay. Ideal way to do it is use a lane wise approach. Everybody did it? Attendance? Okay. Who are you people? Where were you? Huh? You need manual? You need manual? Yeah, you should ask UOB to give you like a new phone or something. It's their system. Okay. Yeah. The ideal thing is to do the lane-wise approach. Okay, where you assign observer to the lane. Okay, because from the lane then you have a sequence of movement, right? It will not be simultaneous. So if I have two lanes going straight and I assign one observer, then he will be making multiple counts at the same time, right? Because both lanes are having vehicles which I'm counting. Okay, clear? Clear or not? And keep one thing in mind, I showed you earlier as well with the speed studies. When we are counting, how do we write it? What is this? Like a chopping meat, huh? Yes. How do we count it? It's lines, right? Lines. Okay. It's not like if there are two vehicles, I'll put two here. Okay. I have to make like two lines. Okay. So my work will increase. So the good thing is that you can do it, if you can do it, is to go lane wise. One observer for each lane. But again, then you have the restriction. Okay. And we saw in the example which we did in lecture 2, how do we deal with if you have more lanes and less observers. You can have breaks and you can fill the breaks with some calculations. And again, something which we looked at in lecture 2, that manual observation needs appropriate breaks. Okay, people have to drink water, they have to shift, they have to change their pens and papers and check notifications, take selfies and all these things. Okay, important, right? And get arrested as well. Okay, I told you what volume are we counting at the intersection? When the vehicles are doing what? Exiting the intersection. Okay. Now suppose there is a very big traffic jam and there is a queue of vehicles to 200, 300 meters, right? Okay. So the volume which we are actually counting is not the demand. It's not how many vehicles are trying to go from the intersection. Okay. What happens when volume is above capacity? Tell me. Demand is above capacity. What happens to volume? It will be equal to capacity, right? It cannot be more than capacity. We looked at a case in lecture 1 where actual volume can be less than capacity as well because of a bottleneck. Okay. So if you are counting, I see a big queue, okay, to where my eyes can see there's a queue. But my count shows what? Either capacity or something less than capacity. Actually on intersection it will be less than capacity. I just noticed it yesterday. Because when there's a big queue, the vehicles, we will discuss it later on, I will mention it. But on intersection, if you have a very long queue, the volume will get less than capacity even without a bottleneck earlier. Okay, it's because of the queue effect. Vehicles are coming slowly. So it will be less than capacity. Now does it make sense that I have a very long queue and I'm counting and my count does not even reach capacity? What good is this doing me? I took a count on the intersection and the count is showing less than capacity. and I have a big traffic jam on the highway, on the intersection. So is this count useful for me? The count which I did. It's not useful, right? It's not showing me the real picture. Okay. So then we have to shift to getting the arrival volume. Okay. So now I'm interested in the arrival volume. In this special case, I'm interested in the arrival volume. So how do I know when to shift? The normal case is you take departure volume, exit volume. And then there is a special case when you have a big queue and you need the arrival volume. Okay, the first thing is, how do I know I have to shift now to the arrival volume? So they have given two conditions according to the type of intersections you have. You can have intersections with signals and you can have intersection without signal, right? Okay, intersection with signal. So you see the signal is red. Okay, and then it becomes yellow and green and yellow. Okay, in this time, before it becomes red, is all the queue gone from the previous red? Then it is normal. Okay, so there were 10 vehicles in the queue. Signal become yellow and red and green and yellow, and in this complete time, all these 10 vehicles, those 10 vehicles which were already in the queue, they are gone. So the next red will have a new queue. Okay, it will not have any vehicles from the previous queue. This is normal. This is normal. But there were 10 vehicles in the queue. The signal became yellow and green and yellow. Only 8 of these vehicles left. So when the new queue begins, when the new red begins, it is beginning already at +2. Those +2 are from the previous red. They are not new. They did not just arrive at the intersection. They were already waiting. They did not get the chance to move. Got it? Clear? This is the situation in which you will shift. Okay? And this is called as queue buildup here. Okay? And it is obviously unstable because at every red you are having more queue. The queue is not clearing. Queue is increasing. Okay? So this is considered unstable and it's called as queue buildup. And in the last topic with the delay discussion, I called it something I forgot. I will remember it till next exam. Okay. But there's another term which I used in there. Okay, you can have a look. But the point is, you shift to arrival volume on a signalized intersection if the vehicles during red cannot clear in the immediate green. They are waiting for more than one red. Okay, that is queue buildup. It is an unstable condition. You shift to arrival volume. Okay, so this is for signalized. If it is unsignalized, it's very easy. Okay, you count how many vehicles are in the queue now, and you do it 3-4 times. Okay, so I do it now. I will do it maybe after 30 seconds, and then again after 30 seconds, then again after any number of seconds. Okay, it's not important. Okay, but if it is unstable, we are calling it what? Queue buildup, right? Queue buildup. So after every 30 seconds, what will happen? Queue will build up, right? Queue will increase. Okay, so it's very easy for unsignalized. You don't have to wait for any red and green and look at how many vehicles, which vehicles were there previously and so on. Okay, if there were 10 now, after some time they are 12, after some time they are 15, it's queue buildup. You shift to arrival. Okay, so normal case, without queue buildup, you take departure volume. Special case, queue buildup, you take arrival volume. Okay, and these are the conditions how you know the shifting paradigm. Okay, now the problem with arrival volume or the long queue. Okay, now queue is building up, right? Queue is building up. Okay, so the cars at the back of the queue, they are not at the same place. When the queue is increasing, the back of the queue is going where? Back, right? It's getting longer, right? So if it was, so now I said, okay, this is the queue, the end of the queue. So any car which will come here, I will count it. Okay, but the end of the queue is not here now. After 10 seconds, it will shift because the queue is building up. Okay, so I don't have any fixed point of observation. When I was doing it in the normal case, it's the stop line. Car crosses stop line, I will count it. I don't have to move forward and backward, right? But with queue build up, I want to count the car which comes. But the car is not always coming at the same point because of the queue. Okay? And the queue is increasing, but at some point it will move as well, right? So it's not only going back. At some point it goes forward as well. Little bit, but it does. Okay? So practically it is not possible, even if I put cameras, it's not possible for me because the camera does not have infinite scope, right? Okay, so now it is doing 50 meters, the queue is 50 meters, fine. After 2 minutes, the queue is 100 meters. Okay, I have to go and adjust the camera again and so on. Okay, Ali will always have bright ideas, yes?
Use drone to remove the
Use drone, yes, very good. Use drone and get arrested again. It's illegal in Bahrain. Ask him,
permission will be okay.
right? Okay. So yes, we can use drone, yes. Other countries will do that, yes. But now what we will do, we look at the equation by which you can calculate arrival volume using the normal counts, okay, the normal counts, the departure counts, okay. So this is the equation you have. So you want arrival volume for time interval I. Let's say time interval I is between 2 and 2:15 p.m. So time interval I is 15 minutes, okay, starting from 2 ending at 2:15, okay. So I is from 2 to 2:15, okay. And this is I want to calculate. What I can get easily is departure, okay. I can calculate easily departure, right? I can count it. When the vehicles move from the stop line, I can count it. So this is my normal count. So I will do the normal count. Okay, this is my normal count which I will do. Clear? Okay. With the normal count, when time interval I finishes, okay, this is the end now. So I finishes at 2:15 p.m. for example. So at 2:15 p.m. at 2:15 p.m. not from 2 to 2:15, no, at 2:15 p.m. one value, okay. I will count how many vehicles are in the queue now, okay, and that is the queue number of vehicles in the queue at time interval I, at the end of time interval I, okay, got it? And I minus 1 will be when then? At what time? Huh? The time interval was 2 to 2:15. So NQI is at 2:15. So NQI minus 1 is where? When?
14.
Huh?
14.
At 14? Yes. I is the time interval. Okay. So if I finishes at 2:15 p.m., I minus 1 finishes at 2 p.m. Okay, so this is the start count. Okay, the starting count. Okay, so normal count of departing vehicles, exiting vehicles, end count of the queue, start count of the queue. When the time interval started, what was the count? When the time interval ended, what was the count? So I'm not doing it in the whole 15 minutes. I'm just doing it at the start and end only. Between them, I'm doing what? The normal count. Okay, so at 2:15, sorry, at 2, I come, 10 vehicles in the queue. Now start, I will put this number, NQI minus 1, and start counting my departure volume. Okay, when 2:15 happens, I'll stop this and again look at how many vehicles are in the queue. Now there are 8. So that 8 will become NQI. Got it? Okay. Let us have a look at this example. So we have data taken from 4 to 6 p.m. 2 hours of data. They counted the normal one, the departure volume. Okay. This thing. Okay. And then you can see the count. Okay. This is only NQI. Okay, it's not the starting count, it's only the ending count. It's only the ending count. So this 0 was taken at what time? 4:15. Okay, so this is NQI for this time interval. For this time interval, it will become what? NQi minus 1, right? Clear or not? Everybody?
Again.
This is taken at 4:15. So for this time interval, it is NQi, number of vehicles in the queue at the end of time interval, right? For this one, for this row, this 0 becomes what? The number of vehicles in the queue at the start, right? Clear or not? Okay. End of previous is the start of next, right? Okay. So for each time interval, we want to calculate the vehicles which have arrived. Okay. So they already decided that it's the situation where we shift. Okay. So we don't have to guess what is happening on the field. Okay. So for the first one, okay, how many vehicles departed? 50. How many in the queue? 0. How many in the queue before? It's not given, I will assume 0. Okay. So 50 departed, 50 in the queue now, and there was no queue before as well. Okay. So I will assume what? All these 50 were the ones who arrived in this time interval, right? So arrival and departure becomes equal. VA equals VD plus NQ minus NQ minus 1, right? Okay. I minus 1, sorry. Okay. So VD is 50, NQ is 0, and I'm assuming because not given, so the previous one is also 0. So 50 plus 0 minus 0, right? Okay, what will happen to the next one? Same, right? Huh? NQ is 0, NQ minus 1 is also 0, okay? So this is your departure and this is also your arrival. Clear or not? Clear, everybody? Okay. The shift will happen or the change will start to happen from here, because now I start to see the queue which maintains till the end of the time period. So I'm looking for this one now, this one, the third one. Okay, 62 plus NQ, which is 5, minus the previous queue, which was 0. So there was no queue before. 62 vehicles left in this time interval and 5 are still in the queue. So total how many came? 62 plus 5. Makes sense, right? Okay. So this will be 67. Okay. Next one, obviously there is no 0 here. So you have 65 plus Q now 10 minus 5, which is 70. Okay. So 65 left in this time interval, but at the end I had 10 vehicles in the queue. Did all of them come in this time interval? No. 5 out of these 10 are from the previous queue. Okay, so actually how many came? 65 plus the difference of the queue. Got it? Clear or not? Okay. You can continue with the rest of the table. Okay. I will give you a check here when you finish your calculations. Okay. Now you see again 2 zeros are here, right? Okay. So this, for this time interval, how much arrival I have? Look at the first and the second case. Okay. When the previous queue is 0 and the queue now is 0, arrival equals to what? Departure. Okay. So in the end, you have 2 zeros again. So this value will be equal to arrival. Got it? Clear now? Okay. But this is not the check. This is just like you should know it. Okay. If the previous queue is 0 and the queue now is 0, arrival equals to departure. Okay. This is like for each time interval. But the check is, you see how much was the queue at the beginning. What is the beginning queue? 0, right? What is the ending Q? 0. So in the 2 hours, I did not start with any previous Q. Okay? And when I finish the 2 hours, there is no Q left. Okay? So in these 2 hours, if 469 vehicles came, no Q before, no Q in the end. 469 vehicles came, or 469 vehicles left. So how many came? 469. Okay? So after you calculate the arrival for each time interval separately, you add them together, you should be getting this one. Okay? Clear or not? Clear? Okay. Let's say there was a queue of 5 here. In the end, there was a queue of 5 here. So the number of vehicles which left, 469 plus 5. Clear or not? Because out of all the vehicles which came, 5 are still in the queue. Got it? Clear or not? Okay. Or you can just apply the same equation but for the whole 2 hours. Okay, it will give you the right number. Clear? Okay. If this is happening at the signalized intersection, the counting is steady. We know the signalized intersection, they classify the movements in time. All movements are not happening at the same time, right? So then you can use your observers in a better way. Okay, so you know the signal for left turning and straight are different. So I can assign the same observer for left turning and straight because it will happen different times. Okay. Another thing is the cycle time. Okay, the signal cycle is what? What is the timing of one cycle of the signal? From red to red. Okay, from the start of one red to the start of the next red. Now you know if you are doing it manually, I will give you a total time interval. You have to count for these many minutes, right? And for these many minutes, there could be some break period as well, right? Okay, so you actually have 3 time intervals. One is total, one is break, and the third one is your actual counting period, right or wrong? Okay, so total is 1 hour, let's say. Okay, then you have a break of 5 minutes. So the actual is 55, right? Actual counting is 55. So there are 3 time intervals. All these 3 time intervals, okay, must be, or your cycle length must be a multiple of, no, sorry, the other way around, yes. These 3 time intervals should be a multiple of cycle length. All 3 of them. Your break period should be a multiple of cycle length. Your total period should be a multiple of cycle length. And total minus break, actual should also be a multiple of cycle length. Got it? Clear? So you are counting for 1 hour. Okay? 1 hour means 60 minutes, right? This 60 minutes should be a multiple of cycle length. Okay, so if cycle length is 2 minutes, it's a multiple. Okay, 3 minutes, multiple. 4 minutes, multiple. 7 minutes is not multiple, right? If the cycle length is 7 minutes, then 60 is not multiple of 7. Okay, so then you have to change the total time. Got it? Okay. Your break period is 5 minutes. So 5 minutes should be a multiple of cycle length. Okay. So again, if your cycle length is 3 minutes, then this break period is not good because 3 is not multiple of 5. Got it? Clear or not, everybody? Clear? Very good. Put it, send the message, clear. Okay. Now, what is the logic behind it? Why we are saying it should all be multiple? Because what happens? If you see signal green, okay, if I only count to half of the green, my count will be less, right? Is it less because of the volume? No. It is less because you did not count the full period. Got it? Okay, so if you do not make multiple, so let's say your counting period is 5 minutes and the cycle length is 3 minutes. So they are not multiple, right? Okay, so what will happen in 5 minutes? You will count one full cycle, 3 minutes, and then you will, for the next cycle, you will only count 2 minutes. In 2 minutes, you will not observe full volume, actual full volume departing from the intersection. Not because there is less volume. It is because you interrupted your cycle. It is because you interrupted your count. Okay? So I will only interrupt the count when the cycle is finished. Okay? Another rule, normally all the counting and all the observations which are done at the intersections, they start at the start of red. Because that is a stable time, right? It's not the start of the movement. Okay? And I end at the start of red as well. Okay? So those two stable time instances. Okay. You got the point now? Okay. This is how you can represent your counting volume on the intersection. Okay. You see the numbers are showing the directions. Okay. And then you can see the total in each direction as well. Right? Total in this direction, 750. This is divided into 3, right? Okay. Total in this direction, this one is coming from 3 different directions. Okay. So you can see the different movements and you can see the total as well. And you see the basic information which is given at the top. Another way of showing it, okay, is just showing the total in each side. And the movements are shown with the lines. Okay. Arrowhead and tail shows you the direction of movement. So arrowhead means going this way, tail means going away from it, right? Okay. And this is called the intersection flow diagram, where you see the scale here as well. The scale is a representation of number of vehicles on that side. So all arrows and all tails are not of the same size. All arrows and all tails are not of the same size. And they do not depend upon the size of the road, they depend upon the volume in that direction. Okay? So the highest volume is where? Where is the highest volume? Which one has the highest volume? Left one? Yeah. So this should be the biggest tail. Okay? And the lowest one is where? Where is the lowest one?
At the right.
At the right. Okay? So this should be the smallest one. Clear?
Can you repeat the scale?
When you are making the arrowheads and tails, you have to select a scale according to the size, according to the volume. Okay, so you can see they have selected a scale here. If it is 6,000 till 8,000, I'll make it up to this much. Okay, and so on. This is what they adopt in Bahrain from Ministry of Works. Okay, so usually the intersection count shows, they have count for full day as well, by the way, but it is shown in a tabular way. So when they go for detail, the table only shows total. Okay, so there is another representation of intersection counts which is adopted by Ministry of Bahrain, Ministry of Works in Bahrain. That only shows you total or each direction separately, but this one you can see all the movements, right? Okay, so normally if you have to do it for part of the day, they focus on 3 hours: the morning peak, the evening peak, and the afternoon peak. Okay, basically there are 2 peaks and 1 non-peak. Basically, this is what the idea is. But in their terms, morning peak, evening peak, and afternoon peak. So in every direction you see 3 values. Okay, you can see the timing here at the top. Okay, and total is not given, you have to do the total yourself. Okay, so this diagram does not show the total, as I already mentioned. For totals, they have a separate table. Okay, so they make up like a Excel sheet, Excel file which has multiple sheets. One of them is this one, and then they have the one which has the total as well. You can see the name of the road and any specific landmark you have, they will mention it. Okay. So we have talked about segments, we have talked about intersections. Now we talk about networks. Okay. in some cases, we want to study the traffic volume on the entire network. Okay, and obviously it's a big thing, right? I told you one intersection can take 16 or more than 16 people as well, or it has more than 16 movements, right? Now imagine one entire network. It will have multiple intersections and multiple segments, right? Okay, so there are two types of network studies. One is called limited network, the other one is called statewide network. Okay, in simple words, one study which is done for a specific facility, a specific building. Okay, that is limited network. So a limited network study is done for a specific facility or a specific building. Okay, and then we have the statewide program, the statewide counting, the statewide network, which is done by the government for studying their roads. Okay, so this one has a special purpose. That one is part of their regular maintenance and operation and so on. Got it? Okay, so now we are discussing the special one, the one which is done for a specific building or a facility. And this is, by the way, for major facilities in Bahrain, this is a requirement. Okay, so anybody comes up with a new project, I'll build a 20-story building, I'm building a new hospital, I'm building a new university for some unknown reason, then they have to do this sort of a study. Okay, so I just gave you an idea about what could be a specific facility which will require this, and this is normally by law. Okay, this is normally done by law. The government will ask you, okay, you are going to build a building which is so big, you need to do a traffic study of the network around the building. Okay, and the reason is what? Anybody? What is the reason? Yeah, you have to do they call it the impact study, traffic impact study. Okay, so they will, it's only one, counting is just one part of limited network. Limited network study is only one part of traffic impact study. Okay, so any new development, which is a big development, requires a traffic impact study, and traffic impact study requires limited network counting. They have to count first, right? They have to know what is happening right now. Then they will see what will be the impact later on. Got it? Clear? Okay. So since it's a big network, so I cannot do the full counting at each and every location. Okay, so we take a sample of a count for any type of limited network, for any type of network study, whether it is limited network or the statewide network. It is impossible to do the full count of each and every segment and intersection in your network. So we have to do some sampling. Okay, so for example, we have done the sampling where? Where did we do the sampling earlier? You did for your project as well. Where did we do the sampling? Sampling for what? Volume? You will not, by the way, because just he mentioned it, there is no sampling for the volume in your case. You have just a segment, two directions of volume, you will take it. That's it. There is no sampling. There is no sampling. Speed, right? Speed, you do the sample, you calculate sample size. Okay. So once you calculate the sample size, you have to do some calculations to see what is the general trend. Okay, that's why we plot the graph and we do the percentile and the standard deviation and the mean. So what are all these things telling you? What is the general trend in the whole population? Same principle will go here. Limited network is too big. I cannot do the full count. I'll take a sample of the count and then I have to do some calculations to see the actual picture, to see the actual trend. Got it? Clear? Okay, how do we do the sampling? First of all, you will identify highways and areas in your network which are similar to each other. Okay, we call them subgroups. small networks in your big network. Okay, so this part of the network has all arterials and it is in the commercial area. This part of the network has all collectors and it is in the residential area. Okay, so this will become subgroups, sub networks. Okay, smaller networks. So before you start the sampling, identify areas and highways which are similar. Okay, then in each subgroup, so you have now different subgroups, right? Different smaller groups of highways and segments. Okay, in each subgroup, you will divide the locations into two categories. In each subgroup, you will divide the locations into two categories: control counts and coverage counts. Control counts and coverage counts. Okay, control counts are those which are the full counts. Control counts are full counts, but they are at some locations. Remember, they are at some locations. Okay, and coverage counts are sample of the full counts. Got it? Okay. Control counts. So you are divided the network into subgroups. In each subgroup, you will identify or classify locations into control counts and coverage counts. So at some locations, you will do the full count. At some location, very few. And what do I call them? Control counts. At the remaining locations, I will do coverage counts, a sample. Got it? Later on I will show you the examples. Okay, but coverage are sample, control are full. Coverage are more, control is less. So if I have 50 locations, I may do coverage at 40 of them. The remaining 10 can be control. Got it? So control is a full count, but it is only done at few locations. Coverage is sample, and it is done at more locations. Got it? And this is in each subgroup. Okay, some points regarding control and coverage count. First thing you have to keep in mind is that the ratio. So I gave you the example, you have 50 locations. Now somebody comes and says, since control count is full, it will require more effort, I will only do it at one location. The remaining is how much? How many locations remaining? You have total 50. You are doing control at 1. Remaining is 49. So the ratio is 1:49, right? So this is not allowed. The maximum you can go up to is 1:20. Okay, 1:20. So if you have 50 locations, okay, if you do control at 5, okay, so the remaining will be how much? 45, right? 45. Okay, 45. So what is the ratio? 1 is to what? 5 and 45. What is the ratio? 1 is to? Huh? They ask you for your high school diplomas, right? At the time of admission or no?
10%. 5 over 50, right?
1 is to 9. Don't give me other logics. 1 is to 9. Okay, 5, 45. The ratio is 1 is to 9. So this is good now. Got it? Okay. Okay. Subgroups I already mentioned that you are doing it in each subgroup, and subgroup means same type of location and same type of highway. Same type of location, same type of highway. Okay, same type of location, they mean land use. They are using the term land use, meaning the type of area you have. Land use means the type of area you have. Okay, residential, commercial, educational, industrial, port, whatever. Okay, so you are doing it within each subgroup. You cannot take count from one subgroup and apply it to some other subgroup. You cannot take count from arterial and mix it with collectors. Got it? Clear? Okay. Yeah. All counts are taken at mid blocks. Okay. Mid block means segments. Mid block means segments, not intersections. Not intersections. This is what they are saying. Okay. So in counting, in these counting studies, network counting studies, we do the counting at segments only, no intersections, no intersections. Okay, and yeah, if the client, you have to make sure that all segments are covered. So no intersection is covered, but all segments must be covered. Got it? Clear? So you have 50 segments, you have to cover all of them. Okay, but all of them will not have control. Few of them will have control, some of them will have coverage. But if you have a segment which does not have control and which does not have coverage, this is wrong. Got it? Okay. Intersections not required.
It's about the segments.
Huh? If you have 50 segments in your subgroup, all 50 segments must have either control or coverage. If they are not covered at all, if there's a segment, you did not do control count on it, you did not do even a sample count on it. This is wrong. Okay? Intersections not required. Intersections not required. If the client comes and says, there's an intersection in my network, I need count on this network. Oh, sorry, count on this intersection. I can still give him the count using the highways from which the count is coming, right? Okay? So I'm talking about this intersection. Let's say there's an intersection here. And I already covered all the segments, right? So I know how many vehicles are on this side, how many on this side, how many this side, how many this side. Okay? So I can combine all of them and give him the full count of the intersection. Got it? Clear? This is what I told you guys, right? You can do it like this. Okay. So very quickly, this is the Eastertown campus. Okay. So let's say we are doing it for this campus, a limited network study for this campus. We want to see when we came from here, how did the life become better there? It did not, by the way. Okay, but we need to identify the subgroups. The subgroups. Now you see, all of this is educational area, right? And all of these are small streets. So this can be one subgroup. Okay. Then all these segments, they are on the same highway and more or less the same area, right? Same mix. Education here and whatever is here. Okay. These segments, another subgroup, if they are not from a different area. Okay. This one, another subgroup. Got my point? Okay. So you need to identify the subgroups, and obviously you need to identify the extent of your network as well. My network is up to what? Okay, you need to identify. Is it up to only this triangle? Okay, or should it include all these things as well? Okay, so on the basis of that, you will identify the subgroups. Clear? But subgroups is type of area and the type of height. Clear? Any questions? Okay, thank you.